We shall overcome, we shall overcome, we shall overcome someday. Oh, deep in my heart, I do believe we shall overcome someday. We shall overcome, we shall overcome, we shall overcome someday. Oh, deep in my heart, I do believe we shall overcome someday.
Good afternoon, dear students. How are you? Hopefully you are well. I'm back again and we will complete the rest of that chapter. The chapter State of Matters and Pressure. This class is both for the standard 9 and 10s. In our last lecture, already we have learned about the definition of pressure. We have learned about the density, its definition, its dimension, and what is the SI unit. Already we have learned this. Now today we are going to discuss about Archimedes Law and buoyancy, rotation and immersion, causes of accident in waterways, and the Pascal's law. Today's topics. So let's start. Hopefully you will enjoy. Firstly, I am going to show you the Archimedes Law. What is Archimedes Law? There is a saying that Mr. Archimedes, when he just invent this theory, when he gave us this definition, that time he was in a bathtub. He was taking a shower. Suddenly when he just put himself into the bathtub and he saw some of the water from that bathtub is floating. And that time he thought this theory, and there is a saying, he started running in the road and telling that's Eureka. Okay, and that time the people was thinking that probably Archimedes got mad. But no, he was not mad. He gave us a very, very interesting theory. And now we are going to see what is that theory. He says that if our body is immersed in a liquid, the weight of the body is reduced by an amount equal to the displaced liquid. A little bit correction here. In your textbook, you will see that they are mentioning the liquid, but I am feeling comfortable to say that it's fluid. You can change the liquid by fluid. Why I am using fluid? You may ask me why I am using fluid. Fluid are that types of substance which can be flow, and liquid is liquid, so you can consider the liquid as a fluid and the air is also a fluid. So what is the definition? I am going to say you again. If our body is immersed in a liquid, the weight of the body is reduced by an amount equal to the displaced liquid. So that is the theory given by the Archimedes. Look here, I have drawn a figure here. So this is a beaker and it's water. In water, here's a substance. The height of that body is h. The height of the body is h. And from the water level to lower level of that body, the height is the h2. And the height of the upper level of the body from the water level is h1. Now tell me, we can write down easily that h2 minus h1 equal h. Isn't that? H2 minus H1. That means this portion upper, the height from the upper level to the lower level of the body, and the height from the upper level of the water to the upper level of the body is H1. Then H2 minus H1 equal H. Got it? Now, the thing is, suppose I put this body in this liquid substance, some of the water will be displaced. Now the question is, how much water will be displaced? Okay, I am telling it again. Suppose you have a full glass of water and you have a coin or a stone. If you put that stone in this glass of water, what will be happen? Some of the water will be displaced from that glass of water. Can you imagine how much water will be floated? Very easy. The amount of floated water will be the same amount of the weight of that object or the body. That means we can easily say that the losing weight and the displaced water weight or displaced liquid weight is always equal. Got it? So now another things I have told you here right now, the buoyancy. What is buoyancy? Buoyancy is nothing but a force. What type of force? Suppose you have a football, or you are taking a balloon and you are pushing that football or balloon into the water. What do you feel? You feel that someone is kicking that balloon or the football from the water. Or if you just stop pushing or pressing force, that balloon or the football will jump. You will feel that maybe someone just kick the football or the balloon from the water. This type of force is named as the buoyancy. Now, we can easily say that the resultantness force of an object, how will be that? Okay, so in our previous lecture already we have said that P equal F by A. Isn't that? P equal F by A. So what will be that? F equal P into A. Right? P into A. Here, if we want to find out the upward force, that will be the H1, height will be H1, the density of the water is the rho, acceleration due to gravity is the g, so we can easily put down that F1 equal H1 rho g into A. Okay, again, what will be the reverse force? That will be the F2 equal same way H2 rho g A. Okay, so as I told you, the buoyancy will be, as I told you, the resultantness force. What will be the resultantness force? That will be F2 minus F1. That will be F2 minus F1 equal H2 rho g A minus H1 rho g A. Okay, A rho g is common. That will be H2 minus H1. That will A is rho g. So the buoyancy will be A is rho g. A is rho g is the buoyancy. Buoyancy for what? Buoyancy for this figure. Okay, got it? So what will be the unit of the buoyancy? As I told you, buoyancy is one kind of force, so the unit of this buoyancy will be Newton. So already we have discussed about the Archimedes law and the buoyancy. Now our next topic is going to the flotation and immersion. Flotation and immersion. Okay. As I denoted, now we are going to discuss about the flotation and the immersion. What is flotation and what is immersion? Flotation means that a body or the something will be float into the liquid or the fluid. And the immersion, that will be, it may be sand. Okay. So flotation, suppose I'm writing W1 and W2. What is W1 here? W1 is weight of the body, and W2 weight of the displaced water. So here I have written W1 and W2. So W equal weight of the body which can be immersed or the floated, that weight of the body, and weight of the displaced water, the amount of water which can be displaced. From this W1 and W2, we can write down three conditions from that. What is that? Either W1 is greater than W2, W1 is less than W2, W1 equal W2. These three conditions, W1 equal W1 is greater than W2, W1 is less than W2, W1 equal W2. What will be happen when W1 is greater than W2? That means the body of the weight is greater than the displaced water weight. What will be happen? The body will be totally immersed. What will be happen? If W1 is less than W2, the body will be floated. W1 is W2, that for that condition, the body will be immersely floated. That means if the weight of the body is greater than the weight of the displaced water, that body will be completely immersed. If the weight of the body is less than W2, that means displaced water, the body will be floated, as the cork sheet. If you put a cork sheet on a water, that will be floated. That type of floating. W1 equal W2. Immersely floated. Immersely floated, that means, if I give you an example, suppose probably you have seen that a banana tree on the water. Okay, that will be immersely floated. Now the question is, a piece of rod is easily floated, immersed in the water, but a larger ship which is made by a heavy iron, how they are floating in the water, isn't that? Okay. Suppose a weight of a iron rod is 5 Newton, and the covered area of that iron rod a little bit tiny, so the displaced water will be a little bit. That means the water weight of that displaced water is very smaller than the amount of weight of the body, so that piece of iron rod will easily immersed. Again, suppose you give that, that means you bring that iron rod and make a iron sheet. So the area will be increased, but the weight will not. Area will be increased, but the weight will be not. So when you put this iron rod, iron sheet into the water, what will be happen? The covered area will be larger, so the amount of displaced water will be also larger. So what will be happen? That iron sheet will be floated. Got it? Now we are going to see the causes of accident in waterways. Causes of accident in waterways. Okay. It's a matter of sorrow that every rainy season or there are large amount of accident occurs in our country. That's very pathetic. What is the reason of this type of accident? Can you imagine? There are many reasons. So most important reason of that accident is overpopulation. Suppose carrying ability of a ship is 50%, okay, but some of our greedy ship owner or their illegal authority just sometimes carry the twice or thrice times of the people, as 100 or the 150. What will be the result of that? The area of that ship, the volume of that ship is unchanged. You can never ever change the area of the ship. But when you put the people 2 times or the 3 times, what will be happen? The weight of that ship will be increased. For that reason, the weight is increased but the area isn't. What will be happen that time? The amount of displaced water will be smaller than the weight of the ship. As a result, in a mid-river, the ship will be sunk, the ship will be immersed, and the pathetic accident is happening randomly in our country. So what should we do? We shouldn't take more people than we shouldn't take more people rather than its ability. So only reason of the accident is carrying more people, that means increasing the mass of the ship, mass of the body. Okay, and another reason, there is also another reason, that means our rivers are not so deep to carry this amount of people. That is also the reason. Okay, now we are going to discuss Pascal's law. Pascal's law, this is our final topics, Pascal law. So now we are going to discuss about the Pascal's law. So what is Pascal's law? I'm going to derive the Pascal's law. If pressure is applied on a liquid or a gas enclosed in a container from outside, the pressure is transmitted equally and acts perpendicularly on the surface of the container in contact with the liquid or the gas. That means if we want to apply this Pascal's law, we also need a container which is enclosed, and this container should be fulfilled with a liquid or the gases. That means in my previous lecture, as I told you, the liquid and gas both are the fluid. So you can fulfill this enclosed container by the fluid, and what will be happen? Suppose, look at the figure. Here's two different containers. Here's a cylinder and another cylinder is here. And this cylinder is connected. And there's our water. It's fulfilled. Suppose this is the fulfilled by water. Here, this is the piston. That's another piston. Here we are applying the force F1 and we will get the force F2. Force F1 and the force F2. Suppose the area of this piston is A1 and this is the A2. A1 and A2. Look, as I told you, if I put a pressure, so here's the force and the area. What is the relationship between force and area? That's connected with the pressure. So P equals F by A. What is the force? That will be the F1 by A1. Applied pressure is F1 by A1 here. According to the Pascal's law, the same amount of pressure will be filled into this cylinder. Suppose I am pushing this, the pressure will be that, that and that. So here's the pressure will also be. If I can write a P1 equal P2. If that is the F1 by A1, what will be here? F2 by A2. So we can write down F1 by F2 equal A1 by A2. This is the relationship between force and area. That means the Pascal's law, F1 by F2 equal A1 by A2. Okay? So F1 by, in your textbook probably there is a formula that is the F2 by F1 equal A2 by A1. The same things. You can write them also, F2 by F1 equal A2 by A1. So this is the Pascal's law. Another things I have forgot to tell you, that this Pascal's law is also named as the Force Enlargement Law. How will that? Okay. It's a little bit trick. Probably these things is not discussed in your textbook. Don't worry, I am showing you that things. According to the Pascal's law, they told us to bring an enclosed container. Suppose this is that container. This is that container. And this container is totally fulfilled with the liquid. Right? These dots are the liquid. Suppose I am putting a piston is here. Piston is here. And the area of this piston is A1. Another piston that is larger than the first one, that is A2. It's the larger than the second one, that's the A3, and it's a little bit larger than the A4. So these are the pistons. These are the pistons. Suppose I am putting force, that means pressure, that's the 5 Pascal. 5 Pascal pressure is here. And the area of this and the area of this piston is 2 meters square, A equal 2 meters square, and the applied force will be, so the F will be P into A, that means 5 into 2 equal 10 Newton. So applied force is 10 Newton. We are applying 10 Newton force here. Suppose the area of this A equal 3 meters square. As I told you, the pressure will be same. So P will be 5 Pascal, but F2 will be 5 into 3 equal 15 Newton. Interesting. We are putting 10 Newton on the first cylinder. Here we are getting 15 Newton in the second one. Again, if the area will be 4, then F3 will be 4 into 5, that is the 20. Same as 5 into 5 equals 25 Newton. The pressure is always equal. 5 Pascal, 5 Pascal, 5 Pascal and 5 Pascal. Second, third and fourth piston will assume same amount of pressure, but their force has increased. 15 Newton, 20 Newton and 25 Newton. That's the reason this law, another name of this law is named as the Force Enlargement Law. That means force will be applied. If you put a little amount of force, that will be increased this amount. I can show you an example. Have you ever seen a hydraulic press? That means you may see that sometimes the taxi driver, car driver or the truck driver, they are changing their tire, or the weight of that car, the truck is too much loss. Okay, so it's quite impossible to pull that truck by 2, 3 or 4 persons. But most interesting is the driver is using a hydraulic press and pressed by its leg or the hand, and the truck is easily pulling. So the driver is pulling a little amount of force there, but applied force is enlarged too much. Okay, so the resultant force will be used. Suppose he is applying 5 Newton and getting 25 Newton. That's the Pascal's law. So that's all. Hopefully you have enjoyed my class. Okay, take care of yourself. Have a nice day. Bye bye.